Okay, today we're going to be talking about specific heat. Specific heat is defined as a property of a substance that describes its heat transfer. Mathematically, specific heat is defined as the amount of heat that's absorbed or lost divided by the mass of material times its change in temperature. Okay, so we could look at it like this: specific heat is equal to the heat over the mass times the change in temperature. If we want to go ahead and rearrange our equation before we discuss it a little bit more, we can do that and get up all of our possible options. Specific heat times mass times change in temperature is equal to our heat. Our mass is equal to our heat over the specific heat times the change in temperature. And our change in temperature is equal to the heat over the specific heat times our mass. Okay, so we've got four different arrangements for this mathematical equation. And we have to remember here, in terms of temperature change, delta T is equal to T final minus T initial, or delta T is equal to T2 minus T1. With specific heat, our delta T value may include a positive or a negative value. And that's important when we're discussing the amount of heat that's transferred between two substances. Now, specific heat, I said earlier, was an identifiable property of a substance. Metals generally have small specific heats, less than 1 calorie per gram degree Celsius. So that magical number, 1 calorie per gram degree Celsius, is the specific heat of water. At that magical 20 degrees Celsius and 1 atmosphere of pressure, the specific heat of water is 1.0 calories per gram degree Celsius. So generally we look at things that have a specific heat less than 1 calorie per gram degree Celsius as a good conductor, and things that have a specific heat greater than 1 calorie per gram degree Celsius as a good insulator. The calorie unit is the English unit of heat. If we want to talk about it in terms of metric units of heat, that will be 4.184 joules per gram degree Celsius, because we have a conversion factor between calories and joules where 1 calorie is equal to 4.184 joules. Now this calorie here is an energy calorie. An energy calorie is much different than a food calorie. A food calorie is 1,000 energy calories. Okay? So if you were to go buy a Coca-Cola in a 12-ounce can and you were to drink that can, it's got somewhere, around 200 calories? That's 200 food calories. So it has 200,000 energy calories, which is the amount of energy that would raise 2,000 grams of water by 1 degree Celsius. So there's a lot of energy in food. There's a lot less energy in substances when they're undergoing, on a gram by gram basis, energy transfer because of a chemical reaction. Specific heat values allow us to choose items. If I want a cup of coffee, I'm going to get a cup of coffee in a styrofoam cup. Why? Styrofoam has a specific heat of about 20 to 30, depending on the type of styrofoam, calories per gram. Whereas if I had a metal coffee cup, I would have a heat capacity less than 1 calorie per gram. So I can carry around hot coffee in a styrofoam cup. I cannot carry around hot coffee in a metal cup that's uninsulated, because all of the heat will transfer from the coffee through the metal, because it's a good conductor, to my hand, and my hand will get burned. So we can use specific heat to identify a substance. We can also use specific heat to determine the usefulness of our substance for whatever application we happen to have.